Given, an integer array nums. You start at index 0. From index I you may jump forward by 1 up through nums at I steps, staying in bounds. A valid path to the last index is guaranteed. Return the minimum number of jumps to reach the last index. Leetcode 45, Jump Game 2, Example 1. From index 0 you can jump 1 or 2 steps, land on index 1. From index 1 you can reach index 4 in 1 jump. That is 2 jumps total, which is optimal. Output is 2. Example 2, a different array, still 2 jumps from index 0 to 1 to 4. Output is 2. Start at index 0, the value there is 2. Your first expansion only lets you step onto indices 1 or 2. Picture a searchlight bracket over that window, that is the first wave of where you may land. Stay in this wave for a moment. Pretend ghost copies stand on 1 and 2. From 1, value 3 reaches all the way to 4. From 2, value 1 only reaches 3. We only care about the best next reach across those options, 4 wins. Now imagine the sweep index marching 0, 1, 2, the right edge of this first wave. When it hits 2, we have finished exploring everything this wave offers, so we count 1 jump. We carry forward the furthest reach we saw, 4, and slide the searchlight to the next strip of new indices we can touch next, 3 and 4. In this second wave the searchlight already covers the last index. The moment that happens, we stop scouting deeper, no extra jump is needed. Counting the jump we just took plus this wave gives the minimum number of jumps, 2, to cross the array. Classical greedy linear time method, 1 pass, incrementing the jump count when the scan reaches the end of the current reach. Current marks the right edge of the wave you are closing with your current jump count. Farthest is the furthest index any cell in that wave can reach on the next step. They are 2 different roles. We initialize jumps to 0, and both current and farthest start at index 0. Place I at index 0. The value is 2, so from here you could land as far as index 2. Update farthest to 2. Now I equals current, both at 0, so we must commit a jump, increment jumps to 1 and snap current forward to farthest, which is 2. Everything from index 1 through 2 is what we explore next. Move I into the new range. At index 1 the value is 3, so you can reach index 4. Bump farthest to 4. No extra jump yet, we only refresh the scout. Advance I to 2. It matches current again, so we take a second jump, jumps becomes 2 and current becomes 4. That already covers the last index, so the sweep can stop. Minimum jumps is 2. Edge case, if n is 0 or 1, you already stand on the last index, so the minimum jumps is 0 and the main loop never runs. Pseudocode for Jump Game 2. Function minJumps takes the array nums. Let n be the length of nums. If there is at most 1 cell, you already stand on the last index. Return 0 jumps. Initialize the jump counter to 0. The current jump wave initially ends at index 0. Track the farthest index reachable from the wave so far. Loop I from 0 through n-2, the last cell needs no outgoing step. From each I, extend farthest using I plus nums at I. When the scan reaches the end of the current wave, increment jumps because you must open a new wave. Stretch the wave boundary to farthest. Return the total number of jumps.